in section 6.2, problem 1. So this one is another one of those, like example 1, where we're given some kind of constraint on what x and y add up to in this case, and we're trying to maximize the product of x and y squared. So again, the idea is that we would like to identify the thing that we're trying to, in this case, maximize. I'm going to call it P for product. So we want to maximize the product of x and y squared. Okay. So as we've done in a lot of these other problems, the thing that we're trying to optimize, we would like to have it as a function of a single variable. So to do that, we take the constraint and we solve for one of the variables. I'm going to solve this for x because x is just by itself, it's not squared. So I'm going to get x is equal to 105 minus y. And so from that, we can then eliminate one of these variables. And I'm going to go ahead and call this p of y now. Again, that's not p times y, it's p of y, meaning that p is now going to be a function of y alone. And I can do that by taking this x value, plugging it in for the x there. So I'm going to get 105 minus y multiplied by the y squared there. So p of y, if we distribute, will be equal to 105 y squared minus y to the third power. And as we've seen with all of these other optimization problems, the next step is to find the critical numbers. So we do that by taking the derivative. So p prime of y is equal to 210 y minus 3y squared. Okay, and then again, we set this derivative equal to 0. So if I set that to 0, I can factor out a 3y from that. So I'll get 3y. And if I factor out the 3y, I'm going to be left with 70 minus y. So this is set equal to 0. This is going to give me two answers, y equals 0 and y equals 70. Okay, now the question says find two non-negative numbers. Well, 0 is not negative, so we kind of have to consider it. Although it's pretty clear that it's not going to give us the maximum value. Because if y is 0, what's x going to be? It really doesn't even matter. But if y is 0, if I plug a 0 in there, x is going to be 105. Well, 0 times 105 is 0. That's definitely not going to be a maximum. So that one's not the answer that we're looking for. 70 is the one that we really want here. So if y is 70, what's x? Well, if y is 70, again, we can get x from that. X is equal to 105 minus y minus 70. That's going to be 35. So our answers, our solutions here are x equals 35 and y equals 70. And if these are the two x values that we have, then two things are going to happen. The product is going to be a maximum, and the sum is going to be 105. Remember, the constraint says that our two values have to add up to 105. So the point here is that of all the x and y combinations that are going to add up to 105, this combination in particular is going to give us the largest possible value for x times y squared. Okay?